Hey guys, how you doing? It's Coach Scott, part three of our Unit 3 review. Part three of our Unit 3 review. So let's do some math with this, right? Let's do some math. So any type of math I'm going to give you, I'm going to give you the knowns that you need to do the math. All right? I'm going to. So let's think about a problem. Let's say you're out there on the basketball court. Man, you're just sweating away. You're over there in flex time, and man, you got a game going. You're dunking left and right. You're defending, but man, you're sweating up a storm in that shirt, right? So while you're sweating, the water vapor um, from your body it absorbs 100. Let's give it 175 kilojoules of energy. Let's write that down now so we know what we got. So it absorbs 175 kilojoules of energy. That's a lot of energy coming from your body. There's no temperature change. How much of that water, what's the mass of that water? How much water did you lose as you were sweating? So what's our temperature and time? Well, there's no temperature change. So we're going to be like that. That's it. No temperature change. We know that. Now we know we lost some energy, right? We lost some energy. So how much energy did we lose? We got to use the heat of vaporization because we're going from a liquid to a gas. You're sweating it out, okay? It's going away. So that's what we got to use. So I know I've got 175 kilojoules. Now I look on my sheet and I see, oh, the heat of vaporization. H vape is like this vape, VP, is for every 1 gram, I'm going to need 2260 joules. For every 2260 joules, I'm going to vaporize 1 gram. Okay, that gives me something right there. So if I need to know my mass, that's what it's asking for. So that's in kilojoules and that's in joules. All right, so let's do that. Let's go ahead and convert that over into joules. So I'm going to multiply that by 1,000. So that's how many joules I've got. So let's look at this little deal right here. For every 2260 joules, I'm going to vaporize 1 gram. So for every 1 gram, okay, I'm going to vaporize 2260 joules. Well, I was that right. 60 joules. That's going to give me my mass. Wow. So all I've got to do now is take my calculator. Let's see, 175,000 divided by 2260. And that's going to give me 77 grams, 77, let's go one sig fig. 77.4 grams, 77.4 grams of liquid. Wow. So my sweat, 77.4 grams went into the atmosphere. Wow, I lost some liquid there. Might need to rehydrate, rehydrate or die. So that's something to think about, right? That is definitely something to think about. So that's just a vaporization problem. Let's go ahead and correct all this away. Catch it? No, I didn't. All right. Let's look at another one real quick. And again, if something changes, I'm looking at one. I'm always looking at mass. But if there's a change in temperature, then I've got to look at the change of temperature or the delta T. So all delta T is the change in temperature. So let's look at something here, right? Let's look at something. If I can get rid of that. Yeah, I can. I'm going to get rid of that. So here we go. Say I've got 100 grams of water. Ooh, cool. Got 100 grams of water. So my mass says 100 grams of water. 100 G H2O. And it starts at 0. Now it's all liquid water right now. So let's see, 0 degrees C. It came down. I brought it down. And it's going to end up at minus 30 degrees C. How much energy did I use? Well, let's see. Let's do the time temperature thing. That's how we know what's going on. So I've got liquid water at 0. So it's going to what? Hang out. It's going to be liquid and solid, liquid and solid, liquid and solid, until all that liquid has solidified into ice. Then it's going to go down to minus 30. So that's going to be what? Minus 30. Let's go minus 30 degrees. So I've got two phases here, guys. Two phases. I got one phase. I got phase 2. So on phase 1, let's look at that. I'll call that P1. I don't have any temperature change, so I don't have a delta T. So I'm fusing the liquid water into solid water, and I look on my sheet, and I see where I gave you the heat of fusion of water. FUS is what? 334 joules per gram. We can start with that. So I need to know, it's asking me how much energy is needed. So I'm finding my joules, right? So I'll start with a known factor, the heat of fusion. 334 joules for every 1 gram. I don't have 1 gram. I've got 100 grams. So I need 334 100 times. I don't even need a calculator. So I need 100 times 334, or 33,400 joules. Okay, part 1's done. Now let's look at part 2. Let's see. I've got solid water, ice. So now I've got to look at my heat capacity. How much heat can the solid ice hold? I'm looking for solid water. Now look on my sheet here, and it tells me that I need 2.1 joules for every 1 gram and every 1 degree C. That's 1 gram, and that's 1 degree C. So let's see. I started with 100 grams. So what does that tell me? That tells me I need 2.1 joules 100 times, or 210 joules for every 1 degree C. Put a times there so you can see what I'm doing. So I need 210 joules to lower it 1 degree C, or change it. Well, I didn't do that. All right, I changed it 30 degrees. Let's see. That's my change of temperature. So if I need 210 joules for every 1 degree C, then I need 210 joules 30 times. All right, I can do my math. I'm going to hit my calculator and do 100. Get off. 100 times 2.1 times 30 degrees. I need 6,300 joules. All right, that's my grams. We don't get messed up. So I need what? 6,300 joules to take that 100 grams of water at 0 degrees C, freeze it, and bring it down to minus 30. That's how much I need. I can do the same thing going up, right? If it's at 0 degrees C, all right, let's go ahead. Let's do that one. I've got 100 grams of water. Let's erase all this. Let me get my little eraser thingy. I didn't get it all, but I got a lot of it. Oh, eraser thingy. I still got that 100 grams of water. All right. Let's see what my time is. 10 minutes. This will be the longest one. It's at 0 degrees C. It just melted. And I'm going to bring it up. Now, I've got 0 degrees ice. I got ice at 0 degrees. It just started melting. And I'm going to raise it to 40 degrees C. Okay, there's a good one. So it's 100 grams. Initially, I start out at, in this ice, the ice is 0 degrees. That's all that's there, no water yet. Then I'm going to raise it to, let's have a little fun here. Let's raise it to 30 degrees C. Now we know to bring that ice down, or that liquid water down to minus 30, we needed 6,300 joules. Let's see how much energy we need to raise it to 30 degrees C. So let's see where we're at. We started at 0 degrees C as all solid ice. So we're going to melt it. We're still adding energy to it. So all the ice, all the solid ice is gone. Now I'm going to raise this water up to 30 degrees C. I'll always draw your little map so you know what's going on. So I've got phase 1 again. I've got phase 2. All right, so phase 1, it'll be the same. All right, the heat of fusion is, look again, is 334 joules per gram. So I've got 100 grams. All right, and let's see, heat of fusion is 334 joules for every 1 gram. But I've got 100 grams, so I need 334 joules 100 times, or 33, 4, 0, 0 joules. Did I do that right? Yes, I did. All right, so I got phase 2. I've got to think back to the previous one. We're going to have both of them together. All right, phase 2. Okay, now I'm going, my change of temperature is from 0 to 30. Okay, so I've got 100 grams. And let's see, the the capacity of liquid water is 4.18 joules. You know what, I didn't add those two together in the first problem because that would not have been right. So 6,300 plus 33,400 on that first problem, my fault. And if we need to, I'll answer that in class. So the heat capacity is for every 1 gram and every 1 degree C, I need 4.18 joules. Okay. So I raised it up 30 degrees. So for every 1 gram, I need 4.18 joules. Well, I've got 100 grams, so I need 4.18 100 times, or 418 joules. Okay, so then I need that for every 1 degree C, I need 418 joules in this particular instance. 100 times 4.18. But I raised it 30 degrees C. Both of the problems had a change of 30 degrees. Let's see. Times 30. So there, I need 12,540 joules. To raise it 30 degrees. That's twice the amount of energy that I needed to freeze it down to minus 30. Minus 30, I only need 6,300. So to heat that water up, I need more energy. It's holding more, the liquid water holds more energy. So I need a total of 33,400. I need a total of 45,940 joules, or let's go to 2 sig figs. Sure, 46,000 joules, or 46 kilojoules. The other one, let's do this right. The other one, 40,000, 39,700 joules, or 40 kilojoules. So to go from solid ice to 30 degrees C, I needed 46 kilojoules. To go from liquid water down 30 degrees to ice, I needed 40 kilojoules. Huh. Water's magical. Just think about why that is. That's a good thing to do. So anyway, guys, this is Coach Scott Chemistry. You can do this, all right? And that's how we do it, and you guys have got it made. So guys, hullabaloo, connect, and I'll see you later.